Hey, math analysis. I had no idea this happened to me again. So I guess I just found out that the video ended at this example. So I'll repost a second part to the video. Anyway, this is the sum formula. And to figure out the first term, you're going to plug in a 1. So 3 to the first is just 3 times 2 is 6. And you know n is 8 because it goes from 1 to 8, so that means there's 8 terms. And then a sub 2, I'm going to plug a 2 in for I, and I am going to get 18. So r is 18 over 6. And so I know r is 3. So now I've got, sorry, it wrote over that a little bit. So anyway, that says 6 times 1 minus 3 raised to the 8 over 1 minus 3. And then I rewrote it down there because you couldn't see it. And then you just plug it into your calculator. All right, on number 9, a job pays a salary of $30,000 for the first year. During 29 years, the salary increases 6% each year. What is the total lifetime salary over a 30-year period? Well, remember, your increase is 1.06, not 0.06, because you make your salary from the year previous plus the additional 6%. So S sub 30 equals 30,000 times 1 minus 1.06 raised to the 30th over 1 minus 1.06. So you plug that into your calculator, and that's how much money you get. Obviously, it's a lot of money, but you are not going to be saving it all. You're going to have to spend it. Okay, so number 10, you have $3,000 to deposit in the IRS over a 40-year period, and the interest rate is 10%. So remember, your R is 1.10, not 0.10. So 1.1. And it's over a 40-year period. So you're using the same formula because you're adding the sum. So it would be 3,000 times 1 minus 1.1 to the 40th over 1 minus 1.1. So make sure you're plugging this correct in your calculator, because if you don't know how to plug it correctly in the calculator, you won't get the right answer. So there is the answer, and there it is to the nearest cent. Okay, number 11. As a hot air balloon rises from Earth's surface, the air in the balloon cools. If the air is not reheated, the balloon rises more slowly with each minute of flight. Suppose that after 1 minute, a hot air balloon rises 120 feet. In each successive minute, it rises only 60%. So this one, R is 0.6. 0.6. Because it's rising less and less each time, not more and more each time. And so N equals 10, and so you plug it into the formula. And then you would plug that into your calculator. So you get that in your calculator. And there you go. Okay, moving on to the infinite sum. So an infinite sum goes on forever. And this, when you raise 1 over any number and you raise it to infinity, that number is going to be 0. So 1 over 5 to the 100 is almost 0. So that's why this formula, the portion of 1 minus r to the n, becomes 0. So this only works when, that was a mistake there, so please write in the right thing. The absolute value of r is less than or equal to 1, or r is between -1 and 1. So it does not have an infinite sum if r is greater than 1. So if it's 2, 3, 3.5, 4, or if it's like -1.5, -2, -3.5, only between 1 and -1. Otherwise, you would say the infinite sum doesn't exist. So in this case, you would take the second term divided by the first term to get r. So that number is between 1 and -1. So you just plug it into that infinite formula, which is just the first term divided by 1 minus r. and you would get 9. Okay, so there is a famous Greek philosopher that talks about certain paradigms. And so one of them is, okay, imagine you are 124 feet from the doorway and you keep going half the distance. So that means the second time you go 512 feet, then you go half of that, and so on. And if you keep going, will you exit the doorway? So the idea here is, let's find the infinite sum when r is 1/2. And so the first time you walk, so does that infinite sum equal 1, 2, 4? So it basically says, okay, the infinite sum. But the idea of an infinite sum is it approaches that but never actually reaches it. So think about it. Will you ever leave the door? I'm going to leave you with that to think about. Have a great day, and sorry about the confusion on the video.